Okay, imagine for a second you could write the fundamental laws for a brand new universe. A digital economy, a complex AI, you name it. And you could know with absolute mathematical certainty that it would never, ever collapse. Well, today, we're diving into a system that's designed to do just that. This is Principia Fabrica.
So really, the entire project, the whole grand idea, boils down to one single massive question. How do you build a universe that doesn't collapse? How do you write the rules for a new digital reality and make sure it doesn't just spiral out of control and completely tear itself apart? You know, this isn't just some abstract thought experiment. It's the central challenge for anyone trying to build a complex system that's meant to last.
All right, so to really get our heads around the solution, we have to start with the problem. And the problem has a name: divergence. Just think of it as this: ghost in the machine. This constant risk that any complex system, if you don't keep it in check, is just going to eventually spiral into total, complete collapse.
Picture any digital process running. As it goes, these tiny errors or little feedback loops can start to build on each other. And without some fundamental rule to stop it, that growth just goes exponential. It's a runaway train. That's divergence.
And what happens when a system diverges? Well, you get chaos. Pure chaos. The system's own rules start to contradict each other and break down. The whole structure just dissolves. Information decays into useless noise, and any hope of predictability is just gone.
And that leads to the final, inevitable stage: collapse. A total structural failure. The beautiful digital universe you built just comes crashing down because its own internal logic couldn't handle its own infinite potential.
So, to be a little more precise here, the fundamental thing we're talking about, the basic building block, is what's called a digital process. It's really just a sequence of states, one thing after another, that changes over time based on a set of rules. So the whole game is figuring out how to stop this fundamental process from blowing up. So, how in the world do you solve for infinite collapse? Well, the answer is actually found in this incredibly elegant piece of mathematics. It's a formula specifically designed to tame infinity itself. So let's take a look at the absolute heart of Principia Fabrica. The core idea is actually a three-step process, and it's brilliant. First, you measure the runaway growth. The system uses a technique called Ramanujan regularization, which is this super clever way to take a process that looks like it's flying off to infinity and assign it one single finite number. It's kind of like calculating the total energy of an infinite explosion. Then, step 2. You use that number to define the system's depth. It sets a hard limit on how complex or how many layers the system is allowed to have. And finally, step 3. You make sure it's built on solid ground. The system checks to make sure there's no infinite regress, no turtles all the way down, guaranteeing there's a real, solid starting point.
And all three of those steps, they're all captured right here in this one formula. Now, don't worry about memorizing the symbols. That's not the point. The key is what it represents. On the right side, you've basically got the two big conditions we just talked about: a hard limit on the system's depth and a check for a solid foundation. A digital process is only considered stable if it lives in that sweet spot where those two conditions overlap. This right here, this is the mathematical signature of a universe that is guaranteed not to collapse.
But look, a formula, no matter how powerful it is really just the beginning. This core stabilization engine is what powers a whole suite of practical tools, what the system calls creative kernels. And this is where we go from pure math to, honestly, a creative powerhouse.
I mean, just look at the sheer breadth of this system. Each one of these is a different kernel, a specialized tool that's built on that exact same foundation of mathematical stability. You've got a science kernel for generating proofs, a cinematic kernel for turning math into epic stories. There's even a video kernel for creating scientific explainers, kind of like the one you're watching right now. This slide right here really puts the power of that engine into perspective. You start with one single input, that elegant formula for taming infinity. And the output? It can be basically anything: a sprawling cinematic universe, a totally robust digital economy, or a scientifically verifiable proof. It's an engine for generating entire stable realities from just a single seed of mathematical law. So, okay, why does all of this abstract math actually matter? What's the point? Because the ultimate goal isn't just a stable formula, it's a stable civilization. It's about taking this foundation and using it to build meaningful, functional, and ethical digital worlds. Let's see how that works in practice. So the architecture is built on three key frameworks.
First, you have DFDF, which basically guarantees a single system, like one blockchain, is stable on its own. Next up is IDFDF, which is what lets you connect lots of those systems together so they can interact and grow without causing a massive systemic collapse. And finally, there's the Fabrica nervous system, or FNS, which is a framework for governance. It mathematically guarantees that decision-making can't get stuck in an infinite loop, ensuring that a decision always gets made.
And all this stability allows for this incredible layered growth, a process they call the Ordinal Ascent. You start at the very simplest point, like a first spark of light. From there, stable layers can be built, one on top of the other, with each step adding more complexity until you reach this horizon, the infinite fabric. A system with almost endless depth, but one that's guaranteed to be stable every single step of the way.
And that brings us to this powerful, really profound thought from the source material itself. Stability is not the end of mathematics, it is the beginning of civilization. It just completely reframes the entire goal, doesn't it? The math isn't the point. The math is the solid foundation upon which something truly lasting and meaningful can finally be built.
So I'll leave you with this question. If you had the tools to build with stable infinities, to create systems that could grow forever without ever breaking, what would you build? A new form of art? A truly fair global economy? A new kind of intelligence? For the first time, maybe the possibilities themselves are infinite and stable. Thanks for joining us.